Namaste. Welcome to Indian Knowledge Systems Primer Course for Children offered by Anaadi Foundation. In today's Bharatiya Ganita lecture series, we will look at magic squares. Magic squares are a part of Bhadra Ganita of the Indian mathematical tradition. A more detailed mathematical study has been provided by Narayana Pandita in his Ganita Kaumudi around 1356 CE. We will learn one of the techniques taught in this text in this lecture. In this work of Narayana Pandita, there are 14 chapters, the last of which is dedicated to the study of magic squares or Bhadra Ganita. This chapter has 60 verses which propound the rules of Bhadra Ganita and 17 verses which use different explanations and examples to elucidate the same. We will learn a few simple magic squares from the systematic techniques that Narayana Pandita has passed on to us. So, as you may have seen in the previous lecture, based on the order of the magic square, Narayana Pandita has classified magic squares into 3 types. We will quickly look at these. The 3 types are Samagarbha, Vishamagarbha and Vishama. When the order of the magic square is divided by 4 and the remainder is 0, that is called a Samagarbha. If the remainder is 2, it is called a Vishamagarbha, and when the remainder is 3 or 1, then it is called a Vishama. These 3 types are classified by Narayana Pandita in his text. The objective of doing this classification is for him to enunciate techniques for each of these different types of magic squares. So, Vishama are magic squares whose order is an odd number, right? This means magic squares of 3 cross 3, 5 cross 5, 7 cross 7, etc. Magic squares whose order is a multiple of 4 are called Samagarbha. These are 4 cross 4, 8 cross 8, 16 cross 16 and so on. Finally, magic squares whose order is an even number that is not divisible by 4 is called Vishamagarbha. For example, 6 cross 6, 10 cross 10, 14 cross 14 and so on. We must keep in mind that it is not possible to construct magic squares of 1 or 2 as the order number. Therefore, here you will see that we begin our examples with the digit 3. Now comes the interesting part where we will actually learn one of Narayana Pandita's techniques for the Vishama squares. As you may remember, Vishama squares are squares which have an odd number as the order. So, this means we will learn using Narayana Pandita's technique how to construct magic squares which, let us say, are 3 cross 3, 5 cross 5, 7 cross 7 and so on. Now, let us say we have to construct a 3 cross 3 magic square for a given set of 9 numbers, right? So, the 9 numbers we will take are simply 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the method given by Narayana for squares with odd number of cells per row or column. So, let us go step by step and figure out using Narayana Pandita's technique how can we construct this Vishama square. So, 1. These are the 4 spots from which we can begin filling the first number in any one of those boxes. Now, as you can see on the screen, this is very important to visually understand how we begin the placement of numbers. First, in our 3 cross 3 square, we mark the north, south, east and west. So, we mark these directions, the cardinal directions in the 4 squares like so. These 4 boxes represent 4 directions and will be very important in our subsequent steps. We have to do a simple task of choosing a direction of our liking. So, we pick a direction and we should keep filling diagonally along that direction. Say we pick north. So, here you can see, let us say we pick north as the direction, right? We must fill the next cell diagonally in the northeast direction. Here you can see this arrow, or in the northwest direction. But your direction should always remain northward. You can either go northeast or northwest. When moving to the next cell, if it goes outside the 3 cross 3 square, we must wrap around. Now we will learn how this wrap around function works. Imagine that your magic square is like a piece of paper, right? If something goes out of this piece of paper, we just turn it around and bring it to the other side. Let's see how this may work. Here you can see that this particular square, which is used as an example, can be wrapped around, right? So its wrapping will give us a new place for numbers where already digits have been filled. Step 4. If the next cell we move to is already filled, then we must go to the cell in the exact opposite direction. So, for instance, if the next cell is northeast and it is already filled by a number, then we must go to the cell in the exact opposite direction, that is the south, because our original direction which we chose was north and the opposite of north is south. Remember, the opposite direction will only apply to the first direction you had initially picked. This move cannot be made diagonally. So let's try putting all these rules into practice by using a simple example, and you will understand how fun and easy it is to actually construct our own magic square. So let's go to step 1. So let's say after figuring out the 4 cardinal directions, I choose north as my favorable place to start constructing my square. So in our series of numbers we had chosen, 1 was the first number, if you remember. So since I have picked north, I will write the number 1 in my north cell. After filling the digit 1, we choose to go to, let's say, northeast next. As you can see here, the northeast direction is outside our square lines. It is falling outside our 3 cross 3 grid. And so what will happen? Now imagine that this northeast direction gets wrapped around. It's a paper which we just fold. If we fold the paper, what happens? From northeast, it will come down towards the bottom. So this wrapping around will mean that our next digit placement must be in the bottom right corner, and that is where we will place our digit 2. Now from 2 is our new position. We must keep filling in the northeast direction since that is what we had initially picked, right? Moving northeast from 2 again, it falls outside the remit of our grid, and so we will wrap it around. Once we wrap it, it goes to the other direction, and here you can see that 3 is placed on the left hand side. Fourth, with the 3 being filled already, we now again try filling the northeast direction. But going northeast from 3, what happens? This move is blocked because the digit 1 is already filled over there. Now if you remember from the rules, if that place is filled and that move is blocked, what do? We go in the exact opposite direction. The exact opposite direction of north is south. So we will place the number 4 right below the number 3. Moving northeast again from the number 4 is fairly easy because we have an empty space here in the northeast and we will write our number 5 there. From 5, again moving to northeast is easy, where we will place our number 6. Now let's say from number 6, where do we place number 7, which is our next? then in the northeast direction. But once we wrap this around, we find that this move is also blocked because 4 is already present in that square. So, as we remember in the rule, if that place is blocked, what we do is we invert the direction, which means we place it, instead of placing in north, we place it in the immediate south, and so 7 will fall right below 6. Repeating our step, the northeast direction from 7 again takes us out of the grid. Let's wrap it around and bring it to the other side, which is where we get 8. Finally, from 8, when we go towards the northeast, we are out of the grid and therefore we wrap it around and bring 9, which is the only last remaining place for this magic square. Now, lo and behold, your magic square is ready, and check if all rows, columns and diagonals give the same magic sum. That is the best way to ensure your magic square is perfectly constructed. You will find that the sum of all the rows and all the columns as well as the diagonals comes up to the number 15. And there we have it. Now let us try one more example to see how we can construct a magic square. So, let's say we pick north as the direction again, but instead of going northeast this time, we'll try going northwest. If we go northwest from 1, here on the screen, you will see it is outside of the square and therefore it gets wrapped around and comes to the bottom 2. Northwest, going northwest from 2, it is outside the remit of our square and it gets wrapped around here on the other side, and that's where we place 3. From 3, if we try going to northwest, 1 is already filled up. So what is the rule? If you get blocked by another digit, just revert the direction. So instead of going north, we go south, and 4 is placed right below 3. From 4, northwest is fairly easy and we place 5 in the immediate northwest box. From 5, we place 6 in the immediate northwest box. From 6 again, we go to 7 in the northwest box, which falls outside of our magic square, and so we wrap it around. But even when we are wrapping around, we see that it is blocked by the digit 4. So, since we are blocked, we will go to the opposite direction and place it in the south. Now, from the position of 7 again, we try going northwest and place 8. 8 gets wrapped around and comes here on this side. And finally, from 8, if you go to the northwest, it is falling outside the remit of our square. We wrap it around and bring it down to the remaining place. Our magic square is now ready. So far in our examples, we have used north as our preferred direction. Now let's see what happens if we choose east as our preferred direction of constructing our magic square. Let's start with the first step. With 1 starting in the east cell, right? If you remember, this is north, this is south, this is west and this is east. So 1 is located in our east cell. We choose to fill the next northeast cell. Now, if you remember, every time we want to fill from the east section, we can go either northeast or we can go southeast. We choose to go northeast in our construction. So, the immediate northeast direction is outside. It gets wrapped around and comes here on the other side. From 2, again our northeast move is wrapped around, comes to the bottom, and that's where we write 3. From 3, if we go to northeast, we are blocked unfortunately by the digit 1, and so what will we do? We will move to the immediate opposite direction, and the opposite direction to east is west. So you will place the next digit westward of your current digit. So 4 comes to the west of 3. From 4, we again go to northeast and place 5. From 5, we move to northeast again and place our 6. From 6, we go to northeast and it wraps around, but unfortunately here again we have 4, so our move is blocked. What will we do if our move is blocked? We will move in the opposite direction, which is west. So we will place our 7 towards the west of the digit 6. From 7 again, we move to the northeast, which gets wrapped around and comes to the bottom as 8. From 8, we go to the northeast again, gets wrapped around, and 9 takes the final and remaining place on our square. This is how we complete our magic square if we chose east as our starting point. Now, in these 4 squares, as you can see, we have chosen different directions to start with northwest, northeast, northeast again with east as our starting point, and southeast again with east as our starting point. Similarly, we can choose, let's say, south as a starting point, and we will move eastward first, westward in another example, and these are 2 instances where we have started constructing our squares from the south. Finally, in these 2 squares, you will see what if someone places the number 1 in the west direction. So, they can go either southwest or they can go northwest to begin. An excellent way to practice this magic square technique is to choose different directions ourselves and try placing numbers in an order so that we construct magic squares from different points of the beginning. Remember, 2 important rules is whenever a digit falls outside your magic square, wrap it around. Imagine it as a piece of paper which you can roll and bring your digit to the other side. This could be in this direction or this direction. Right? The second rule to remember is that whenever we are blocked by another digit in the given box, we just choose the exact opposite direction. So, if you have chosen north, you will place your digit to the south. If you have chosen east, you will place it to the west, and so on. I hope that this technique which we have learnt from Narayana Pandita to construct the magic squares was interesting and also a good challenge for us to learn construction on our own. In subsequent lectures, we will learn more about magic squares and their importance in the field of mathematics. Thank you.